No one wants you. You're so rude. I'm doing your math.
Okay, so limits and continuity. So we've already seen before we did the limit as h approaches 0, so the distance between 2 points approaches 0. This time we're doing the limit as x approaches something. So we write the limit as x approaches a being some number, of a function equals p. So say the limit as x approaches a of the function, the function approaches p. As x approaches a, the function approaches p. So essentially what you're saying is as x, for example, approaches 3, y might approach 6. That's what you're saying, pretty much. So if f of x is defined at x equals a, then substitute in x equals a into the function to find the limit. So just as before how we said h approaches 0, we just subbed in h equals 0. You're doing the same thing. So as x approaches, for example, 3, you just sub in x equals 3 into your function and you find the limit that way. It's pretty straightforward. So, for example, we've got the limit as x approaches 2 for the function 2x plus 1 over x. So all you do is sub in x equals 2. So that gives us 2 times 2 plus 1 over 2, which gives us 5 over 2. So if you actually drew this function on a graph, you would see that as you get closer to x equals 2, the line at that point gets closer, y gets closer to 5 on 2, 2.5. Okay.
Can you repeat that?
If you drew that,
Could you draw it as an example?
Oh, I haven't drawn it. It actually looks something like,
That one.
yeah, it looks like this. Hyperbola. I can't remember the name of it.
It's a hyperbola.
Yeah. Yeah. So we see this is x equals 2. This is 2. This is 3. So that's roughly what the graph actually looks like. So we say like as x approaches, we get closer to here, the line actually approaches 2.5. Maybe that point there. So as the x value is approaching 2, our y value is approaching 2.5. That's all we're saying. Okay. If f of x is not defined at x equals a, you cannot substitute x equals a into f of x. You need to do a little bit of rearranging or factorizing. So for example, We have the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. Now what's going to happen if we just substituted x equals 2 into the function? 0 where?
On the bottom.
On the bottom. And can you divide by 0? No, it's undefined. So what we need to do is a little bit of rearranging, bit of factorizing. So what you want to aim to do, if you've got this undefined x minus 2 on the bottom, you want to factor that out of the top. So see if you can factor out x minus 2 from the top quadratic. Okay, so what's our numerator going to be?
X minus 2, x minus 1.
Yeah, x minus 2, x minus 1.
Why?
You're just factorizing the top. Just changing that into 2 brackets. Yeah, so you got x squared minus x minus 2x is minus 3x plus 2. Yep. And now you'll see that we can cancel out the x minus 2 on top and bottom. So now we actually have the limit as x approaches 2 of x minus 1. Now we can sub. Yeah, sub in x equals 2, so 2 minus 1, it equals 1. Yep. So anytime you get a 0 on the bottom, it's generally you've got to factorize at this stage. Okay. Now, consider the function f of x equals 1 on x squared as x approaches 0. Obviously, it's not going to work if we're looking for the limit as x approaches 0. If we just chuck a 0 on the bottom of the fraction, we can't do that. But we also can't factorize. So it might help if we actually have a look at what the 1 over x squared graph looks like. Does everyone remember? Yeah. It looks like this one. So, as x approaches 0, what does our function approach, or our y? This is 0. Yeah, it keeps going up. It's approaching infinity. So we can say the limit as x approaches 0 of 1 over x squared equals infinity. Because it doesn't matter which side you approach from. You can approach from this side or you can approach from that side. But as long as you're going towards 0, your y value is going up towards infinity. Closer and closer to infinity. Yeah. I guess you wouldn't really say closer to infinity. You say it's getting larger. Not closer to, because there's no end point. Yeah. Okay, what about... Oh, I should add also, as x approaches infinity, what does the function approach? So we'll go with infinity, so that's going up this way. So x approaches 0, y is approaching, x is approaching infinity, y is approaching 0. Yeah, as we're getting further and further that way, our y value is getting closer and closer to 0. As x approaches negative infinity, so going this way, what is our y approaching?
0.
Very good. Make sure you make the distinction between positive and negative infinity. They're two different directions. Okay, what about f of x equals 1 over x as x approaches 0? Again, same thing, we can't just sub in 0 because it doesn't make sense, so we've got to draw the graph so we can think about it. What does a 1 over x graph look like?
1 and 3.
Yeah, that one. Now, this time, as x is approaching 0, what is y approaching? So, yeah, exactly. So you can't just say infinity this time because it depends on which way you approach from, the left or the right. So the notation we actually use is if we're approaching from the positive side of the x-axis, we say as we're approaching 0 positive, because we're approaching 0 from the positive side. And as we're approaching 0 from the positive side, y is approaching infinity. And we can say as x approaches 0 from the negative side, that's this side, y is approaching what? Negative infinity. Very good. And just as before, as x is approaching positive infinity, what is y approaching? Good. And as the x is approaching negative infinity, what is y approaching? 0. Now those two you don't need to distinguish between a plus or minus 0 because they're just both approaching 0. It's only like underneath the limit that you need to say whether it's approaching from the positive or the negative side. Right, so in general, if x approaches a from the left, then it's the limit as x approaches a from the negative side. And if x approaches a from the right, then it's the limit as x is approaching a from the positive side. That you can pretty much work out yourselves, because if you're approaching from the right-hand side of the graph, it's the positive side of x, so it's as x is approaching the positive side of a. And if it's approaching from the left, then it's from the negative side. Okay. Yeah, there's more.
What did the last one say?
Sorry? So as we just saw, we can only use the limit as x approaches a if it doesn't matter what side you're approaching from, you get the same limit. But if you get different limits, depending on if you approach from the left or approach from the right, you have to split it into plus and minus. So for this function, x cubed for when x is between 0 and 1. 5 for when x equals 1, and 6 for when x is between 1 and 2. Now, I'll show you what the graph looks like. This is y, this is x. 3, 1, 2, 1, 2, 1, 2. Okay, it looks like right, so that's just the graphical representation of the function. So you've got y equals 5 when x equals 1, that's that point there. We've got x cubed for between 0 and 1, so that's there, not including that endpoint. And y equals 6 when x is between 1 and 2, not including the 1, but including the 2. So if we are saying x is approaching 1, can we just say x is approaching 1, or do we have to specify which side it's coming from?
Side.
Yeah, which side? Because depending on which side we approach from, y is approaching different numbers. So we're going to say as the limit as x is approaching 1 from the positive side of the function. So if we approach 1 from the positive side, what is our y approaching?
6.
It's this line up here. We're approaching that point there, 6. We're just saying, yeah, you got to look at where the actual line is. So we're going across this line as x is approaching 1. We're getting closer and closer towards y equals 6.
What if it was equals 6?
It would still be 6 because the line is still approaching 6. However, if we approach x equals 1 from the negative side, what is our y approaching? Yeah, it's going up this line here, and it's getting towards that one, this one. And last little bit, continuity at a point. So a function is continuous if it can be drawn continuously, obviously, continuously, without breaking. So the example that we just saw, not continuous because there was tons of breaks in it. It's not, it's just a one continuous line. If a break occurs, we say there is a discontinuity. At x equals a. So if there's a break in the line at x equals 6, we say there's a discontinuity at x equals 6. So the little example we have here, x and y, 1, 2, and 3. between. It's pretty straightforward. It's not a continuous line because we've got the little hollow circle at x equals 3. So we say there's a discontinuity at x equals 3. It means the curve is not defined at that point. So it means every point up into the x equals 3 is defined, but at x equals 3, the line is not there.
So the point is not hollow.
Yeah, it would be continuous, but because there's a hollow point, it means that we don't have the line at x equals 3. So there's a discontinuity there. Sorry?
Why is there a hollow point?
Because that's the question. That's just how it looks.
What would the question say? So you get like
Well-
the hybrid functions, and then you don't say is
Yeah.
there a continuity?
Yeah, you get hybrid functions and they don't match up. They don't join. There's a discontinuity there. It's not a continuous line.
Is that just mean
No, it'd be like
Okay, so we say a function is continuous if 3 conditions are met. Squeeze it in. Number 1. F of x is defined at all points x equals a. So right before here on this example, we got x equals 3 is not defined, so therefore it's not continuous. So you've got to have all points on the line being defined for it to be continuous. Condition number 2. The limit as x approaches a for the function exists. So that's saying doesn't matter if you approach from the positive or the negative side, you've got to approach the same value. So as before, when we had the hyperbolas, I think it was, if we approach from the left side and if we approach from the right side, we get different values. So that's not continuous. Doesn't matter if you approach from the left or the right, you've got to approach the same number. And condition number 3. The limit as x approaches a for the function has got to be the same as f of a. Okay, so for the third one, we'll look to that example. The limit as x approaches 3 for the function on the line as we approach 3 from either side, what are we approaching? Y equals what?
2.
Yep, 2. But the function when you sub in x equals 3, what do you get? 1. So the limit and the actual f of a are not equal. So that's why it's discontinuous. That's the third condition there.
Oh.
The limit as you approach an x value has got to be the same as if you sub in that x value into the formula and you get the same answer. We'll do one algebraically and it'll make more sense.
So basically. Oh. Yeah, wait.
So we've got this function x squared for x greater than or equal to 0 and negative 2x plus 1 for x less than 0. We've got to prove that either that it's continuous or it's got a discontinuity at some point. So we need to meet those 3 conditions. So we're going to look at this point here, x equals 0. Because we know one function is for greater than 0, one function is less than 0. So we know that at that x equals 0, there might be a discontinuity. Because that's where they're supposed to meet up. But they might not meet up. So, first things first. F of x is defined at x equals a. So we got to find f of 0. Right, so we look at this one here. Because that one is inclusive of 0. So if we sub in x equals 0, do we get an answer? We get 0, yeah. It's not undefined, there is an answer. F of 0 equals 0. Okay, the limit, this is the second condition now. We've got to prove that x, as we approach a being 0 from either side, it's got to give us the same value. So as x approaches 0 from the positive side, for the function, so what is it, the first function or the second function? Yeah, so this is the positive side, x is greater than 0. So as we approach 0, as x is approaching 0, the function's approaching 0. Yeah, you sub in x equals 0. The limit as x is approaching 0 from the negative side, now that's the second function, this one. Yeah, so as x is approaching 0, the function is approaching 1. So, does the limit as x approaches 0 in general exist? No, because we're approaching different numbers. So we've already proven that there is a discontinuity at x equals 0.
Just like that. Dirty dog.
Continuity at x equals 0 as the limit of x approaches a for the function does not exist. The limit does not exist.
Well, love it.
I do. Mean Girls reference.
How'd you get them?
So our function is x squared plus 1 and negative 2x plus 1 for x is greater than or equal to 0 and x is less than 0. So obviously we're going to be approaching 0 because that's where there might be a discontinuity if they don't join up. So the first condition, do we have a viable point at x equals 0? Yeah, so it's the first function. And if x equals 0, then y equals 1. So yes, there is a point at x equals 0 that is defined. Okay, next we have to prove that it doesn't matter if you approach from the left or the right, that we approach the same y value. So the limit as x approaches 0 from the positive side for our function. Yep, so approaching from the positive side is the first function. So as x approaches 0, we're approaching 1. And the limit as x approaches 0 from the negative side is the second one. And as x is approaching 0, we're approaching 1. The third condition is that this one is equal to this one. They all equal 1, it's continuous. Continuous. Smiley faces.